Energy balance. What is energy balance? How much energy do I need? Is it possible to consume too much or too little energy? What happens when my energy is out of balance?
Before we begin our discussion on energy balance and how it relates to nutrition, let's take a moment to review some basic chemistry regarding energy. Let's start with the definition of a calorie. A calorie is a unit of measure commonly used in nutrition when expressing how much energy can be derived from food or expended during physical activity. A calorie is the amount of energy necessary to raise the temperature of 1 milliliter of water 1 degree Celsius at standard atmospheric conditions. A kilocalorie is equivalent to 1,000 calories. For convenience, sometimes calorie, with a capital C, is used instead of kilocalories. You sometimes see this on food labels, as we will see shortly. Among nutrition professionals, however, kilocalories, or kcals, are used. We will use the abbreviation kilocalories for the remainder of these lessons.
The amount of energy derived from the breaking of chemical bonds in food is expressed in calories. For example, the energy derived from the metabolism of 1 gram of carbohydrate is 4.0 kilocalories, or 4,000 calories. For protein, we again derive 4.0 kilocalories per gram of protein metabolized. For 1 gram of fat, we derive 9.0 kilocalories of energy. The metabolism of 1 gram of alcohol yields 7 kilocalories of energy. Calories from the metabolism of these and other compounds fuel the body's physiological needs. We will examine carbohydrates, fats, and protein in further detail when we discuss nutritional balance.
Now let's look at energy balance. Energy balance describes the relationship between total energy intake and total energy expenditure. Total energy intake is equal to the total number of calories consumed in all of the food and beverages eaten over a period of time, for example, over a 24-hour period. Total energy expenditure is the amount of energy expended by an individual over the same period of time, for example, 24 hours, as the result of normal daily activities. This includes everything from sleeping to performing intense physical exercise. So, energy balance is essentially a comparison between the amount of energy consumed by an individual and the amount of energy used by the same individual over the same period of time.
So, energy balance is the difference between total energy intake and total energy expenditure. But what happens with major or minor fluctuations in energy intake or energy expenditure? Should we always strive to be in energy balance? What does energy balance look like? Remember that according to the first law of thermodynamics, energy is conserved. It cannot be created or destroyed. Therefore, if we take in more energy than what we utilize, the body conserves this excess energy by storing it for later use. The body can partially adjust to minor increases or decreases in energy consumption or energy usage in an effort to maintain energy balance. For example, the body can respond to the recent consumption of a meal by signaling the brain to decrease appetite. However, a sustained imbalance of energy in favor of energy consumption will result in weight gain, while a sustained imbalance of energy in favor of energy expenditure will result in weight loss. Let's illustrate this with a few simple examples.
We'll begin with Sarah, a healthy 16-year-old with an active lifestyle. Her body uses an estimated 2,400 kilocalories of energy per day for work and physiological functions. In other words, her total daily energy expenditure is 2,400 kilocalories. At breakfast, she consumes 460 kilocalories of food and beverages. At lunch, she consumes 950 kilocalories. For an afternoon snack, she consumes 140 kilocalories. At dinner time, Sarah consumes 850 kilocalories. Her total consumption for the day is 2,400 kilocalories of energy. The amount of energy taken in is equivalent to the amount of energy expensed, so her body is in energy balance.
Now let's look at the energy balance of Jonathan, a healthy 16-year-old with an active lifestyle. His body uses an estimated 3,100 kilocalories of energy per day. At breakfast, he consumes 770 kilocalories of food and beverages. At lunch, he consumes 1,100 kilocalories. For an afternoon snack, he consumes 220 kilocalories. At dinner time, Jonathan consumes 750 kilocalories. His total consumption for the day is 2,840 kilocalories. Jonathan has consumed less energy than he has expended, so he has an energy imbalance of minus 260 kilocalories. This is also stated as a negative energy balance. Initially, the body responds to this negative energy balance with hunger. If Jonathan does not eat enough to bring himself back into energy balance, his body will use stored energy to meet its energy needs. If the negative energy imbalance is sustained, this could result in weight loss. We'll discuss this in more depth when we learn about energy balance maintenance and weight management.
Now let's look at the energy balance of Jennifer, also a healthy 16-year-old with an active lifestyle. Her body uses an estimated 2,400 kilocalories of energy per day. At breakfast, she consumes 520 kilocalories from food and beverages. At lunch, she consumes 1,100 kilocalories. For an afternoon snack, she consumes 150 kilocalories. At dinner time, Jennifer consumes 950 kilocalories. Her total consumption for the day is 2,720 kilocalories. Jennifer has consumed more energy than she has expended, so she has an energy imbalance of plus 320 kilocalories. This is also stated as a positive energy balance. Jennifer's body will respond to an increase in energy intake with a decrease in hunger. Jennifer is currently at a normal weight, but a sustained positive energy balance could result in weight gain. Again, we will discuss this more when we learn about nutritional health. So eating too little energy may cause weight loss, while eating too much energy may cause weight gain. How much excess energy do I need to take in to gain weight? What happens if I eat too little? Where does the energy come from between meals?
It takes a decrease of approximately 3,500 kcal of energy intake to result in the loss of 1 pound of body fat. Conversely, it takes approximately 3,500 kilocalories in excess of total expenditure to result in 1 pound of added body fat. It may be added quickly with a few binges of high-calorie meals, or slowly over the course of time with just a few extra calories a day. Unfortunately, it may be difficult to recognize when we are in a small positive energy balance. Let's take, for example, an increase in our daily energy intake of just 140 kilocalories per day. This is roughly equivalent to the energy derived from one chocolate chip cookie. If a positive energy balance of 140 kilocalories is sustained for approximately 25 days, a pound of body weight may be gained. If sustained for a year, this could result in a possible increase of 14 pounds of body weight, all from one additional chocolate chip cookie per day.
The body is in constant need for energy to meet physiological needs, yet we are not always eating to supply it with energy. We supply the body directly with energy only during and immediately after a meal. During the remainder of the day, the body is essentially in a state of fasting. During these times between meals, stored energy in the form of glycogen, protein, or fat is used to supply the body with the necessary energy. Let's take a moment to examine how the body stores and uses energy. In the liver and muscle, excess glucose molecules from carbohydrates in a meal are linked together to form a branched compound called glycogen. When glycogen stores are full in both the liver and the muscle, the liver converts any excess glucose to fat for storage in fatty tissues, also known as adipose tissue. Excess dietary proteins and fat may also be converted to the storage form of fat. Between meals or in times of fasting, stored energy in the form of glucose from glycogen, as well as stored fats from adipose tissue, and, depending on the length of the fast, muscle protein breakdown, are mobilized for use as energy sources to meet the body's energy needs. In each cell of the body, these compounds can enter pathways that convert the chemical bond energy from glucose, fats, and protein to new high-energy compounds to be utilized by the cell for physiological and biological functions. In this manner, the energy needs of cells are met throughout the body when food is not readily available.
Let's take a moment to review what we've learned. We consume high-energy compounds in the form of carbohydrates, fats, and protein. The amount of energy potentially derived from the complete metabolism of these compounds can be expressed in kilocalories. Our bodies utilize this energy for work, physiological functions, growth, and repair. If the amount of kilocalories derived from the consumption of food is equivalent to the amount of energy used by the body is said to be in energy balance. If the amount of energy consumed is less than the amount of energy used, the body is said to be in negative energy balance, and the body uses stored energy to meet its energy needs. If the body consumes more energy than it uses, the body is in positive energy balance, and the excess energy is stored in the body for future use, resulting in weight gain. Between meals, the body utilizes stored energy in the form of glycogen in muscle and liver, and fat in adipose tissue to fuel biological needs.
So our body's energy needs are met between meals, during fasting, and even at rest. This is true of all living things. Storage of excess energy for times of energy deficit is an essential part of growth, maintenance, repair, and survival. In the next lesson, we take a close look at energy expenditure, including the components of energy expenditure and the factors that affect energy expenditure.